So I'm Kate from LCA and wanted to talk to you all a little bit about water quality. Some of you have heard portions of this talk before, so I'll kind of go quickly through the first part of it and get into the data a little more, which is a little more interesting just from mostly from our water sampling last year. And then I'll talk a little bit about some things that landowners can do on their own properties or towns can do to help improve water quality in our watersheds. I'd be interested, I know some of you guys, and I know this crew's from Monkton, but I'd love to hear where the rest of you all are from, if you don't mind sharing, just so I can tailor my talk a little bit, if you're interested.
Sure.
Okay, Monkton too, okay,
Starksboro.
okay, great. So that'll help me out a little bit anyhow. Feel free to jump in with questions or, you know, answer whatever might come up. We'll see if we can do this properly today. There we go. Okay. So Lake Champlain, as we all know, is a really important and valuable resource to Vermonters. Beautiful spot. We all love to swim, boat, fish, look at the lake. You know, it supports a variety of fish and wildlife. The 2017 Clean Water Report by the state treasurer showed that this $300 million is about what we bring in per year just in tourism based on sort of our natural resources. But unfortunately, Lake Champlain also has some problems. We have these cyanobacteria blooms that you hear about that sometimes close our beaches, make it unhealthy to swim in the water, let your dog go in the water, and can impact other organisms in the food chain as well, including fish, die-offs, amphibian problems, and of course also impacts the economic value of our lake. So whether you own a home on the lake and your property value is impacted by this type of cyanobacteria bloom, or you have to help pay for the cleanup of the lake, which is what we're looking at with this number. The same report that I mentioned estimated that it was going to cost $115 million per year to clean up Lake Champlain to get it to where the EPA and the state have said you need to get it to this, you know, sort of good value and reduce the amount of phosphorus that you're sending into the lake. So, you know, phosphorus is a nutrient. It feeds plants. If you fertilize a house plant or out in your garden, you're probably using phosphorus, nitrogen, potassium. So phosphorus is one of those fertilizers, one of those nutrients that plants use to grow. But too much of it is a bad thing. And so we really have too much of it in our rivers and washing down into our lakes. And the EPA, US EPA, has said, Vermont, New York, Canada, you guys need to reduce the amount of phosphorus going into the lake. You need to reach a certain target value in order to meet our standards. So that's kind of what we're talking about here. And it's the main nutrient that we focus on, but I'll also talk about a couple other sort of pollutants, if you will. A lot of times when people think pollutants, they think whatever, oil washing down into the river, but really phosphorus in this case is a pollutant. Chloride is a pollutant, so something that sort of impacts the waterways.
Does phosphorus mostly come from people fertilizing their lawns, or is it something that's naturally formed, or how does it actually get into the lake?
I'll tell you a little more about that in just a minute.
Yeah. And 115 million a year for how many years?
Oh, I think it was like at least 10 years or something.
Oh,
yeah.
Gosh, okay.
Yeah.
It's not a 1 or 2 years.
Yeah. Yeah. It's a while.
Okay.
So we all really have to work together to solve this problem, because as we know, you know, it's not just the lake owners who need to clean up the lake. It's coming down our riverways and it's coming from our upstream areas, including Monkton and Hinesburg and Starksboro headwaters, washing down our riverways, as you can see in this diagram, and getting out into Lake Champlain.
Where's that?
So that, sorry, go ahead. Yeah. Down in Ferrisburgh.
Oh,
Yeah. Yeah. So when we have these big floods and, you know, big, like we had last year, you see these kind of nasty looking brown rivers. All that sediment is actually carrying some phosphorus with it. So historically, like, especially right after World War II, there was a lot of sort of excess nitrogen and nitrates, and they really encouraged farmers to fertilize their fields heavily. So there was a lot of fertilizer that went on our sort of clay soils. A lot of our areas have clay soils. And that the phosphorus can actually bind to the soil particles. When we have these big rainstorms, you get a lot of the bigger sediments sort of dropping out, right, as they're washing down the rivers. Maybe they settle out in a floodplain or whatever. But these really fine clay soil particles get washed down the furthest and the fastest. So they kind of get washed out into the lake along with the phosphorus that's bound to the soil. So when you see these muddy waterways, it's not just the sediment and the mud that's the problem, but there's actually phosphorus and nutrients bound to the soil.
And it doesn't dissipate naturally in the soil, it always stays there?
Yeah, so it eventually this will obviously settle to the bottom of the lake.
Yeah.
And then there is an issue where essentially if the oxygen in the water decreases, that phosphorus gets released into the lake. And so we sometimes refer to that as like legacy phosphorus. It's not something that we're like putting there currently, but there's already legacy phosphorus in the sediment at the bottom of the lake. And so just having that can add to the phosphorus when it gets released into the water. So this, doesn't just come from soil. It can come from our developed lands as well. So our parking lots and whatnot that all add to the amount of water that actually gets into the stream. So even this building that we're on here, naturally this would have been a forest. Water would have fallen and sunk into ground, maybe somewhere right in this area. But now, it's a building. There's no water getting into the ground here. It may be sheeting off and getting into a stream that way. And so now all the water that normally might have sunk into the ground right on the spot is being shifted and sent downstream. So adding to the amount of water that's getting into those streams and washing down. There are obvious other sources of, fertilizers and lawns and gardens and, a variety of other agricultural, soils and whatnot that are also adding phosphorus. This is just sort of a demonstration of what I was just talking about. Essentially on the natural forested habitat on the left side of the screen, you've got, about 50% of the water that actually soaks into the ground naturally in a forested habitat. About 10% of it runs off on the surface and 40% evaporates. And then in a city setting where you've got, 70 to 100% impervious surface, you now only have 15% getting into the ground through infiltration, 55% of it running off and 30% evaporating. So, this is obviously more of a problem in a bigger city setting, like not so much here in Monkton probably, but if you were in Burlington or South Burlington or whatever, you have a lot coming from that developed lands or urban development. Here you're looking at sort of two different graphs. The left side pie chart is what Vermont contributes to the Lake Champlain Basin as far as phosphorus goes. So you can see like the biggest piece of the pie is agricultural land. So 41% of the phosphorus that we add to the lake comes from agricultural lands. Developed land, so that urban habitat contributes 18%. Forest lands, 16%, and stream channels, so that's like erosion of stream channel banks, is 21%. And just a little portion from wastewater, 4%. Yeah.
Is the gap between the 417 metric tons target and the 631 metric tons basically becoming legacy phosphorus that you were talking about?
Yeah, so the 417 on the right is sort of like our target or our goal. And it's how much we have to reduce that pie by to get to like what EPA has told us that we need to target to meet, to sort of, I guess you could say like unimpair the lake, to get to the point where we can say, okay, we're done. we cleaned it up. And so the greatest percentage reduction there is the agricultural land sector. So you're going from 262 down to 118 metric tons per year. And then some portion of the other sectors are also need to be reduced to reach that goal. One question I've had in the past is about the forest lands and like why are forest lands contributing to phosphorus, right? You would think if it's a natural forested habitat, it should be fine. Essentially our old forest road practices, even some current forest road practices and logging practices, leave roads and erosion patterns that can wash sediment into streams. So we're contributing, those forest lands are contributing to phosphorus in the streams.
But only because of the roads.
Yeah, mostly because of the roads. I mean, certainly there's some that comes naturally from the leaves and whatnot, and other like logging practices, but mostly from roads. And so there is some grant money now available to help people clean up forest roads, right? Like close them out properly so that there's not water running straight down the logging road, directly into a stream. We've done some funny things to our rivers in the past. You're looking here at the LaPlatte River on the left side of the stream. You're looking at the LaPlatte near O'Neill Road and Shelburne Falls Road. It's a little hard to see, but sort of where that arrow points, you can see like curvy sections of river, just sort of goes around and around. That's what a river should look like. That's sort of a naturally sinuous or curvy river. On the right side of the screen, you're looking at the LaPlatte River just a little bit further upstream in the center of Hinesburg. So you've got Route 116 coming down and making that sharp right angle turn. You've got Charlotte Road going off to the west and Silver Street coming straight south. And that's the LaPlatte that you cross over as you're heading from here into Hinesburg. And you can see it's almost a perfectly straight line. There's a little bit of a curve in it. Back in I think it was about the 50s, 60s, Army Corps of Engineers actually came in and straightened stream channels to allow more arable land, or maybe to build closer to streams, made it easier to, if this river's here, then we can do whatever we need to do right up to the banks. But unfortunately, as you can imagine, that makes our rivers move faster and erode more along the banks. And so now we're kind of trying to undo some of that work.
There's been some phosphorus work at that site though, hasn't there?
Not at that particular one. There is an easement on that corner now where they've got, they've done some wetland restoration and built some ponds and like closed up one of the ditches that was, former ag land. We all have seen this well after last year. These more frequent flood events, larger rainfall events are all carrying more and more phosphorus down into the lake. So we all have to work together in our watersheds from, all the way up here in Monkton and Hinesburg down through Charlotte, Shelburne to really clean up the amount of phosphorus getting into the waterways. So I'm going to show you a quick video. This is maybe 2 or 3 minutes long. Just talks about some of the management strategies, talks about kind of the old ways that we did things and then the better way to do things now. And a lot of these are being put into place now here in Vermont. We're very lucky in that sense that we have, some pretty strong regulations and folks who are quite aware of, the best way to do things. But I'll show you this video because I think it's a nice illustration and very helpful to understand. Didn't work in Charlotte the other day either. So let's give it. Practices over in Europe that we are here in the US, all sort of part of the same problems, I guess, and trying to fix some of the same historic problems. Hi there. So I'll just review that really quickly. Some of the 3 management principles that you saw in the video. One, of course, is moving the buildings sort of out of the floodplains and allowing the river to reconnect with its floodplain to flood where we maybe want it to flood, as opposed to the city or the buildings downstream. Slowing the flow down by allowing these meanders to reform in the rivers, so not trying to keep our rivers straight. And then leaving the natural sediments in the stream beds so that we can prevent that like down cutting where the river gets lower and lower and lower. And
Can you explain that?
Yeah. Yeah, so I mean, essentially like so the river is tied to the groundwater. So the groundwater is, the groundwater level is like essentially the same as the river. And so as you like dig out the river, it's kind of sinking and the groundwater is sinking, which means that the banks that are kind of up higher where the vegetation is are those trees or those shrubs or whatever can't reach the groundwater as much anymore. So then they die and then those banks sort of collapse in.
So instead of digging it out, they're just saying, don't dig it out.
Yeah, don't dig it out. Yeah. Okay, so here in Vermont, we have had this is new, so newish in the last 5 years, state regulations. That includes the municipal roads general permit. You've probably seen a lot of like road work on your town roads along the margins where they're digging new ditches and putting in rock riprap or grass lined swales. That's all part of this town permit that all towns have to meet. They have to keep their the portions of road that are connected to the streams up to a certain standard so that there's not just a bunch of sediment washing down off the road into the streams. We also have some new required agricultural practices. And the 3-acre permit, which is it's a permit that developments that have more than 3 acres of impervious surface have to essentially treat their stormwater. Or at least a portion of their stormwater. So even older properties, schools, the cheese plant up in Hinesburg, they all have to do some sort of stormwater treatment to clean up some of the water before it leaves their site, even if they didn't used to have to do that.
What does that consist of exactly? How do you?
It depends on the site and, like what space they have and what they can do there, what the soil type is and all that stuff. But it could be like a rain garden or a gravel wetland. In some cases, it's like an underground treatment system, like a big thing that's buried into the parking lot. It could be natural, it could be engineered. Yeah, it just depends on sort of what they have available for space. Of course, these voluntary conservation measures, this is I believe this is Briggs Farm in Starksboro, where, we're able to sort of conserve the river corridor so that the stream, Lewis Creek, is allowed to meander and natural vegetation is allowed to grow there next to the creek. And those types of conservation measures can help sort of in the longer term. And then monitoring water quality, this is something that we do, LCA does with volunteers as part of a state program. So the state Department of Environmental Conservation pays for the lab samples themselves. We get some funding from towns that we sample in to fund my time or my counterpart Sarah's time to coordinate volunteers and get folks out there with bottles in the streams and taking these samples somewhere between 8 and 10 times a year, and then analyze those data and present them in a way that hopefully is understandable to you all. So when I started with LCA, it was like these Word document reports with Excel tables, and they were like 40 pages long, and I didn't even understand it, much less like be able to present it to someone else. So we now have this nice story map that I'm going to show you here in a minute that has some of the data that you can peruse through and kind of see visually like what the results are from year to year. I just wanted to mention that the state uses the data that we collect, as does EPA, to help understand what's going on in our streams and then to make judgment calls about which streams or sections of streams need to be like called stressed or impaired. So they use the water quality data, but they also do assessments of fish and invertebrates in the streams. And so they go out with their staff and do those assessments. So I wanted to just briefly show you the fish and bug data for the various streams before I show you the water quality data, just so you can get a feel for what that looks like as well. So you're looking at Lewis Creek here, starting at the headwaters in Starksboro. The green dots, dark green, are like excellent fish assessment, if you will, fish data. And then all the way down to red dot, which is poor. So you can see like the headwaters of Starksboro, excellent condition. And I would say that probably applies to most of our forested headwater streams, that they're all in, in very good shape. And then as you start to go down into the valley, you start to hit some of these lighter green, sort of good colors, and a few poor values in there. Similarly for insects, maybe it doesn't hold quite as true here, but mostly pretty good values for insects in the Lewis Creek. And then when we get into the LaPlatte, you can see we don't really have those excellent numbers anymore. We've got sort of good values. And then when you get down closer to, this is McCabe's Brook, that little sort of stream that runs along the west side of the watershed. You can see the little orange segment on there. That orange segment is impaired. So deemed by EPA and the state to be impaired because it doesn't support aquatic life very well. So it's impaired by nutrients. And you can see there that we have a fair value for fish. And when we get into the macroinvertebrate data, we have a couple of poor values. So it really just doesn't support bugs or really fish very well in McCabe's.
Is Monkton in along any of this?
Yeah, so,
areas?
yep, let me take you back. Sorry, should have given you a little more orientation. The central portion here, this town is Monkton right here. Well, I don't know where the end of it is there.
So there's really no actual data from Lewis Creek in regards to Monkton.
Yeah, you've got these 2 points here. So this is Pond Brook and this is Lewis Creek here that are in Monkton.
So that, like that green dot is just in the northeast corner of Monkton.
Yep. Yeah, that light green.
So like Cedar Pond and.
That's just, this is Monkton right there, the
Yeah.
little corner that sticks out.
Right. Yeah, so here's your pond here, here's Cedar Lake, and they don't do assessments in lakes, they only do them on the rivers. So I don't have data to share from lake water bodies. Okay, so I'm gonna click through that. Okay, so I'm gonna attempt anyways to move us away from this presentation and go to this website, ? Which is our data. And I need to figure out how to do that. Huh. Okay, new share. Go to that one. Okay, so if you were trying to find this website to find the data and explore a little bit further, because I can't show you everything tonight. If you go to our website and scroll over to maps is probably the easiest way to get there to load, but it's this first or second map on the list. So water quality monitoring data story map. And that will get you to our data. You'll see here that there are 4 years worth of data on the story map. Up at the top, there's both an introduction and then 2021, 2022, 2023, and 2024. We don't have a nice summary overall, description of every year. I hope to do that at some point in the near future, but it's a little bit of a project to get all the data in the right format and probably potentially hire someone to help me do the analyses. So for now, you have to look at it year to year. But for you folks, I think if you go back a year or two, you'll see some of the LaPlatte data, but this year we're not sampling directly on the LaPlatte. So I'm not going to show that to you tonight. But I wanted to walk through this 2024 field story map. Is that everything on it is like underlined text. It will come into an area or show you that point on the map. And you can read through all the story details about, everything we did and where we sampled. And this is just sort of the overview page. And then we get into details, graphs and maps that show you, what's actually happening at each of those points. So last year, as you can see, again, this is Monkton here. You can't even really see that town line for some reason, but Monkton somewhere in there. This is Pond Brook that comes down, again, not very clear because we're zoomed out pretty far. This is Lewis Creek, and then this is LaPlatte up here, and these are the direct to lake drainages, Thorpe Brook and Kimball Brook. So this is our second year of data collection on Pond Brook. We're gonna do this for 3 years. So right now I just have 2 years worth of data for these 4 sites. We're doing a little bit of intensive sampling up here, sort of around the north end of Lake Iroquois and some of these streams that drain into the LaPlatte. One of the reasons for that is that a few years back, we sampled pretty close to the LaPlatte on one of these streams and discovered that there was really high nutrient levels, both phosphorus and nitrogen. We're trying to figure out like, where is that coming from? So we've kind of moved upstream a little bit and we're trying to sample some of these, little smaller streams that feed into that bigger stream and try to figure out if we can learn a little bit more about what's happening there. This is a lot of mumbo jumbo about flow conditions, which you don't need to know a whole lot about unless you really want to dive, because you can see our huge rainstorm event last year. So these are the flow numbers. The red line that you see that's really close to the bottom there is what we call the low LMM, I don't remember what the other M is, but anyway, it's like the low flow value for the year. So anything that's below that, we can actually compare to the state water quality standard for phosphorus. So the standard that's like allowed or is comparable is like at a low flow event. So if you have anything above that, you can't like statistically say, okay, this meets or does not meet the standard. Last year, as you can see, every single one of those little triangles is above the red line, meaning that every flow sample that we took last year, we can't compare directly to the state standard because they were all above low flow, unfortunately. But it's interesting to see that huge, it might be harder. Yeah, at some point, I think they do recalculate it. I don't know, every 10 you have it again. So here, I just wanted to talk about the 3 different sample parameters that we collect. So we collect a total phosphorus number, which I talked to you about phosphorus a lot already. We also collect total nitrogen at most of our sites, nitrogen being another nutrient that, especially in the east part of the state, is more of a concern, but we don't see super high numbers over here, but sometimes it can be informative to understand more about, what's going on at a certain site. And then chloride as well. And chloride is brought mostly by road salt, winter road salt. And so just looking at those 3 different things, you'll see as we scroll through, there are maps for each of them. And the colored dots on the maps indicate the size, sort of class of the data that we collected there. So this is not like a distinct number, but like you can see the largest circle here had a mean phosphorus level of between 100 and 292 in this case. This, one below it, 27 to 100, below that 15 to 27, and then the tiniest one is 0 to 15. You might wonder why the numbers are so weird there, 15 and 27. That's because those are the state standards for different types of streams. So if you're in like a mountain stream, pretty high gradient, the state standard for phosphorus is 15 micrograms per liter. If you're in like a lower stream, LaPlatte or whatever, it's 27 micrograms per liter. And then the 100 is just random. We just picked that. So you can really see visually, where sort of our healthiest streams are that we sampled last year, those smallest dots, as opposed to those, very, very large, heavy and fun. If you want to really dive into this, there's more information and text about, what we saw, where the highest values were and all that sort of thing. We go into this a little more specifically by grouping. So this is the LaPlatte River and tributaries. You can see these very sort of healthy-ish headwater streams here. And then this is right near the wastewater treatment plant in Hinesburg on the LaPlatte. So kind of certainly above the state standard level. If you were really interested, you could click on any of these points. There it goes. And it would bring up some data about it. So what the mean value was, what the minimum, what the maximum was for all of those parameters that we looked at. Okay, so.
What is the state standard? How do you know what the state standard is for that river?
Yeah, it's it depends a little bit. Sometimes I have to ask the state, like, is this a medium high gradient stream or is it a whatever the other classification is? And they'll tell you. For some of the lower streams, like way out in the valley, they actually don't have a standard. So that gets even more complicated. Yeah. So, yeah, not totally straightforward. But generally I would say like what they call a medium high gradient stream. So like a headwater, pretty steep stream is going to be 15. And then, as it flattens out and goes into the valley, it's probably going to be 27. I won't go into this a whole lot, all the like details of the box plots, but the idea here is that you're looking at kind of the center point-ish of the data in the line that goes across each of these boxes, like this line here. And then you've got some sort of like outliers, like really high value that didn't quite fit here. And then you're looking at the 25th and 75th percentile around of those data around that point. So it just visually gives you sort of a feel for what those points are. And you can see like here, this obviously stands out as being one of the highest values. This is just north of Lake Iroquois on a tributary that feeds into Lake Iroquois in Williston.
A quick question.
Mm-hmm.
So you guys don't actually, you only test the tributaries, you don't test the wetlands and the actual ponds and.
Correct, and that's.
So who does that?
So the state runs a separate program called the Lay Monitoring Program, and they coordinate that. And I believe they have volunteers on various ponds that go out and collect. Lay, L-A-Y. So if you have a lay monitor on your pond, like someone who lives there and just volunteers to do that program, I think then you get those data.
Is that through the A&R?
Yeah, I think it's through the DEC as well.
To see the differences, because, I mean, would you expect phosphorus to be lower or higher in running water? And it would be interesting to see the correlation between the standing water, phosphorus context versus the running water.
Yeah, I think one of the reasons they don't want us to sample in beaver ponds, for example, is because of, right, it's kind of like blocking all the sediment in the pond in that case. So you've got sort of probably an unnaturally high level of phosphorus right there.
Depending on what side of the dam you're on.
Yeah, right, yeah.
We'll go into that.
Yeah, right. So it's a different program anyways. And we also have graphs here for phosphorus that will show you sort of with the flow values. So this is that flow line that you were looking at earlier with the big peaks and whatnot. So you can kind of see where we sampled in relation to those big storm events. And you can see like here, the phosphorus spiked really on some of these sites when we got this storm event. Unfortunately, we sampled right before the really big floods. We don't have data like right here. I wish we did. But it can be interesting to see how the various sites sort of change or don't change maybe with those big storm events. This was the site that I mentioned earlier that had that really high phosphorus value just north of Lake Iroquois. And one of the highest values was like early on in the spring. And so we're hypothesizing anyways that perhaps the farm field had been tilled. And so there was, more sediment washing in that early in the spring before there was much ground cover. But unfortunately, we don't have details of like, oh, they just tilled the field and now we're seeing a lot of phosphorus. I'll have to move it along here, talking too much. So these are your 4 Monkton sites again here on Pond Brook. So Bristol Pond down here, Cedar Lakes somewhere right there. You can't even see it on here, but those are the 4 sampling sites along Pond Brook. And the other 2 sites that you'll see on these graphs are these 2 here. So this is Pringle West and Pringle East, and they both drain down into Lewis Creek a little bit further down in Charlotte. And one of them is more heavily agriculture influenced, and the east one is not as heavily influenced by ag. So to show you these graphs, we've got, like I said, the 4 sites, 3 of them are actually on Pond Brook proper, and one of them's on a tributary to Pond Brook. Right here, so this orange thing is a tributary. This is closest to Bristol Pond, and then this is moving downstream away from Bristol Pond, so Mountain Road and Mountain Road. And then Silver Street essentially. And then this thing comes in just north of Church Road. Right, Ann?
Yeah.
Okay, good, Ann samples there. And then these are the 2 sites I was just mentioning to you in Charlotte, Pringle West and Pringle East. Pringle East and Pringle West. So you can see huge difference between these 2 tributaries that are just, I mean, they're walkable 100 yards apart. But they do come together and drain into Lewis Creek. So interesting to try to figure that out. Okay, why is this one so high compared to the other when they're very similar otherwise in size and everything? Data goes, we had the highest level. So when we sampled prior to this in 2023, the highest level of phosphorus was found at that Silver Street location. We had to switch locations a little bit this year. So it's like, we're moving just downstream from that. And this year, we also, we have sort of the lowest concentrations at that upstream site, but also quite high on that tributary that comes in from just across Mountain Road, just north of Church. Obviously, there's some agriculture up there and some wetlands as well, but pretty high levels there as well. Just it's a little bit of a myth more. We don't have any Charlotters here, right? Nobody said? Oh, one Charlotte? Oh, yes. You want to learn about, I'll tell you about it very briefly if you want to hear about it. Otherwise, I can just.
That's the one that goes underneath the covered bridge at the lake.
That's, that one is Hinesburg. Thorpe drains into like Town Farm Bay from the north. It comes across, East Thompson's Point Road, that area. So yeah, we're sampling a couple of different tributaries to Thorpe. And as you can see, one of these has pretty high phosphorus levels. The other 2 are the pond that's at Sweet Roots Farm on right off Route 7. Used to be the Blueberry Farm or whatever. So just trying to learn a little bit more about what that pond contributes to. Get ahead here and stop talking about phosphorus for just a minute. Talk about nitrogen really briefly. The state standard for nitrogen is really focused on one portion of this total nitrogen that we measure. The state standard is focused just on nitrate. So this total nitrogen that we measure includes nitrate in it, but it also includes nitrate and something else, I think. Total, I don't know. Anyways, this is total nitrogen. We can't compare it to the state standard in short. But what we can say is that the state standard is 5 milligrams per liter. And our numbers, as you can see, so this biggest thing is 5, it's 3 3/4 up to 5. All of our little dots are pretty darn tiny. They're all like in this lower section. So if we consider that, you know, this is like the overall picture of nitrogen and the state standard is 5 for this little portion of nitrogen, we're looking okay. Like we're nowhere near the state standard on any of our sites. One of the interesting things we looked at was this LPT. Let me just click on it. See, cool, right? It zoomed you right in. So if you're curious, where is this LPT St. George 116? Right at Rocky Ridge Golf Course, so just south of 2A. The nitrogen there, although it was still low, it was sort of elevated and in relation to the phosphorus levels, which were actually quite low. So it's kind of interesting to try to figure out why would nitrogen be higher there and phosphorus be lower? Still not really clear. We're going to keep monitoring there and see if that pattern holds over the next year or 2. Could be something like fertilizer. It could be something like wastewater. It could be septic, right? It could be leaking in there.
Upstream of the golf course?
It's essentially upstream of the golf course. It's like
So
right
you're not
on.
seeing a major golf course in there.
Yeah. Like it could be catching a little bit of the golf course, but not a whole lot. We're pretty close to 116 there. But yeah, that was interesting to. As far as chloride goes, I mentioned, you know, our winter road salting. There are other sources of chloride as well. The dust suppression solution that they put on roads in the summer also has chloride in it. Agricultural fertilizers often have chloride in them. So in various fashions, of course, our water softeners also can contribute to chloride. And the state has shown that chloride levels in Lake Champlain are increasing. which is definitely a concern. Over in New York, they had one lake, I'd say it was Mirror Lake, but I'm not 100% clear, that didn't turn over one year because they had such high levels of chloride that like it didn't mix essentially in the spring like it should have. So we don't want that. We want to try to limit our chloride use as much as we can. We have, again, similar to nitrogen, like the standard level is quite high, and we also can't compare to that because they talk about it being a 4-day average in a 3-day period. So you'd have to like sample almost continuously to understand, to like to be able to make a direct comparison to the state standard. But we can still draw, some conclusions just looking at our data. And you can see here again, most of these points are quite. I'll mention one of the sites or two of the sites that we're sampling this year in fairly developed Shelburne are like astronomically high. Like they would be probably the highest color or biggest dye here, which is interesting. Like they're collecting a lot of neighborhood, road salt, and Shelburne is not light on their road salt. Let's put it that way.
Like if there's a lot of road construction going on in that area, because I know like in certain areas of Shelburne and Shaw especially, there's been a lot of work being done. Would that affect the runoff from those sites affect that at all, or is that?
I don't know that road construction would contribute to the chloride levels necessarily. But certainly the road salt use and then like that wash off in the spring. And sometimes we see it in the summer too, where it kind of spikes because it does get into the groundwater as well. And so of concern anyways, even though these points are fairly low, the folks at the Lake Champlain Sea Grant have put out a nice little video on like ways that you can salt or essentially brine your sidewalk instead of like salting, and also about like how much salt it should actually, you lay down, right? And it's like a cup per, I forget how much, like 10 square feet or something. So it's like 1 grain of salt per 3 inches, I think is the rule. That's what will actually help. But if you want to reduce your salt use, they also have a way that you can make like a brine and spray it on your sidewalks before the storm. And that minimizes how much salt you end up using in the winter. There at the bottom of this, a few conclusions or thoughts about what we saw and some of the things that we're going to be continuing with next year. We will be sampling Pond Brook again for the 3rd year in a row, and those sites sort of around Lake Iroquois, sort of west and north of Lake Iroquois, for the 3rd year. And then once we get through that like 3rd year of data collection, we kind of move on so we'll like target a different area or a different tributary to get more detailed data on that area. Yeah.
So for what purpose is this always being a collective?
Yeah.
Yeah,
No, it's a good question. Yeah. Yeah.
Public data.
Right.
Does it give you grant funding? Does it help you
Right.
knock on people's doors?
Yes.
Hey, farmer, you could just do X, Y, Z.
Right. Yeah, a little bit. I mean, a little bit of everything. So certainly the state uses it for, deciding like what waterways need improvement or are impaired. We do use it for, outreach to landowners, like, hey, we're interested in doing this project and here, let's show you why, like the data showing you that your stream needs help. And it can be useful for grant funding as well to just say, hey, like this water body has really high phosphorus levels, or it has, whatever, we need to do this outreach to talk to these folks or to put a project in place here. So yeah, used in many ways. And I think it's also interesting for folks to, just look at themselves and like, okay, what's the stream near me? Like, what does that look like? Because it's not something you can visibly see necessarily, to kind of understand that a little better. Okay, so I'm gonna stop sharing that maybe. Yep, that's fine. We're gonna go back here. We really don't have that much time, so I'm gonna talk really fast. Okay, so the 3 S's, if you take anything away from this presentation, slow it, spread it, and sink it. These are the 3 things you want to do with water to like make it more natural, kind of, work in the way that we want it to, the way it would have 300 years ago before we built and did all sorts of interesting things with our waterways. So we have some demonstration sites around, mostly in the LaPlatte watershed. Examples of how to slow water down. This is a roadside swale where we've put in these sort of check dams. You might see your towns doing these as well to slow water down as it travels down the roadside ditch into the stream with vegetation in between, so the water can kind of settle out and the plants can use some of those nutrients to grow. Spreading water out. This is Hinesburg garage, former garage anyways, moved to the town garage back away from the stream. We excavated essentially the floodplain here so that this stream, which originally had a big berm of sediment here, so it couldn't escape that way, could flood out onto that floodplain area. And we put rocks and logs, can't really see the logs so much, but these are rocks that we installed in the stream to help kind of raise the stream bed up so that that water could flood more easily. And it worked great, worked well last year. It did take out the culvert downstream of it because the culvert was too small, but we still got some nice flooding on our floodplain, so that was good. And then of course, sinking water into the ground. This is a rain garden at Shelburne Community School. And had the kids come out and help plant this, but originally the water, this was like the bus circle, and the water went straight into storm drains around the edges of that bus circle, and then from there piped directly into the creek, into McCabe's Brook. So now the water is able to flow into these depressions and kind of filter slowly through plants and get, you know, some of the nutrients get used up, and then from there it does still go directly into McCabe's Brook, but it's a little cleaner when it does. I think maybe I'm gonna quit there. We can click through these, but a few ideas just for towns, sort of applying, you know, some of these standards to your town, to your private roads as well. The website for the story map, if you wanna learn a little more. Of course, protecting our you know, areas of high public value where there are natural solutions to cleaning up our stormwater. And addressing development that has happened in the past in these flood prone areas. On your own property, you don't want this, you don't want your soil all washing away and eroding downstream. So try to prevent that. You know, you can crown your road, fix your driveway so that the water's not just funneling straight down the road and into the creek. These little depressions or rain gardens can allow water to soak into the soil naturally. Native plants they all have sort of longer roots than our grass system, so they can help, you know, soak up some of that water and use a little bit more of it. And then of course, maintaining trees and wooded buffers along our waterways. And that's not even just our rivers and our creeks, but also our little ditches and, you know, little drainage ways that end up down in the creek eventually. We talked a little bit about fertilizer, salt use, all that stuff. If you happen to live on a lake or a stream, there are a couple programs that will help you assess your property and give you recommendations. So the Winooski Natural Resources Conservation District runs these assessments. You can reach out to them and they can come to your property and make some recommendations for you. And then we also have a new guide that if you want to just walk through and like sort of try to assess your property yourself, you know, figure out if you have areas that need some help. I think there's a copy of your guide here in the library, but I also have paper copies. You can find the online version on our website as well. But it'll kind of walk you through like, what do I look for? You know, what does erosion look like? If I have gutters, like what do I do if I want to stop erosion coming off my roof? How to calculate sizing of a stormwater treatment area, figuring out if your soils can even accept something like a rain garden, or is it just going to sit there and make a big puddle in your yard? Yeah, this is on this manual. Your library should have one too. Charlotte should have one or two, so you can check it out. And there are like a million other resources out there. So in the back of our guide, there's, you know, the rain garden manual and the homeowner resources and better roads manual and all this stuff to get more info. Yeah.
It's a resource, a reliable resource to go to. You want to go swimming and you're deciding, should I go to Kingsland Bay or maybe I want to go down the road to Bristol Falls?
Yeah.
Can I look up the water quality with any And any website that would give me some feeling of, let's stay away from Lake Champlain.
Right.
I mean, they close the lake when it gets bad enough.
Yeah.
How many days is it almost really bad that they're not closing it?
Yeah, that's a really good question.
Could be in it.
Yeah. Yeah, I think it depends on like who the monitor is, because it's all like volunteers, right? It's people who go out there and look at the lake and go, is there a cyanobacteria bloom here today or not? And then like how quickly do they report it? And then how quickly does it get to the right people at the town for them to close down the beach, right? So it's like several steps along the way. There is a cyanobacteria monitor page like through the Lake Champlain committee, I think, and should also be on the state website. They also have an email, like a weekly email list, but I'm not sure that that's going to help you on the day-to-day of like, do I go this place or that place? Because I think there's probably a delay of at least a day or two before the data actually gets to where it needs to be for you to see it. You could, I mean, something that I've learned a little bit about, I don't know a lot about, but just like how to identify a cyanobacteria bloom, you know, what does it look like? Well, yeah, but like, yeah.
Cleanliness short of the bacteria.
Oh, short of the bacteria, yeah.
Swallow the water. And
Oh, right.
E. coli.
E. coli, yeah.
Better to go swim in a stream, generally speaking, than going and swimming in the lake, maybe, I don't know.
Right, yeah, I don't know either. I mean, I think I would say after a storm event, I wouldn't swim in any of the things, you know? If it just had a big rain, just stay out.
Yeah.
But yeah, I think that's a tough one for sure. So I think with that, I'm done. Happy to take any questions, though.
You showed the Hinesburg, the plot there,
Yeah.
the phosphorus did not meet state standards, right, at the
Yep.
sewage treatment plant?
Yep.
Is that something they're fixing or fixed or? it's just-
So, yeah, they are fixing the wastewater treatment plant itself, as the state has required. So we will be contributing less as far as phosphorus and nitrogen goes into the LaPlatte. So that's a good thing. I hear there are plans in the works for a floodplain restoration there too, because as you know, our lagoons were like right next to the LaPlatte. So they're taking out one of the lagoons that I think flew around there. And hopefully gonna restore some of that floodplain access.
There was just a project done, I can forward you all the information, it's one of the guys on our collecting. Robert from one of the river places, Robert Hines.
Yeah, I'm
Yeah, he just did a big project down in there,
okay,
so I can forward that to you, just
Sure.
for your own benefit, to see what you did down there.
okay,
But I
yeah,
know
great,
that was really directed towards a lot of phosphorus.
okay,
Because
gotcha.
he used that, he actually testified in front of the legislation.
Oh, yeah.
So it used that as an example of the cost savings and the phosphorus
Right.
savings, so I can send that to you.
Yeah, I think I have seen that now you mentioned, it. It's just upstream from the
Yeah,
downstream and there it
it's
occurs.
amazing.
Yeah,
You mentioned about there's a real spike in nitrogen phosphorus early in the spring.
yeah, there's, yeah, I think the spike that we saw was really only it was like at one site, and we thought it was kind of unique because we saw it, you know, despite like there wasn't any big rain event or anything, but we saw this spike anyways. It was agricultural, and I don't know if they spread, I don't think they do spread there because I drive by there somewhat frequently, and it's not like, I never see trucks out spreading or whatever. So I guess I don't know the answer to your question. My guess would be that some of that spreading certainly contributes to phosphorus and, you know, nutrients, especially when it's on bare soil and it ends up get a rain the next day or it's on frozen grounds. Yes. Yeah. There are certain like required agricultural practices now beyond just like the spreading dates. Farmers are supposed to have, I think it's like a 10-foot, you know, permanently vegetated buffer on you know, like ditches and stuff that drain into the waterways. So that theoretically, that water is not going directly into a waterway.
It's not much of a buffer.
Yeah, it's not. I think it's 25 feet on like a real river.
Actually, it's like 10 feet, like, that are, looks like this.
Yes, right,
Like that.
yeah, it's a little different, yeah. And they can hay it, it's not like it has to be treed, it's just like they can't spread there and they can't till it or whatever. Better than what we used to have, but maybe not as good as we could have. Who knows?
You always hear me being like, it's really, really dirty.
Yeah,
So I guess the more. Well, because of the questions. They kind of close. Then beyond that, actually,
yeah, it does. Yeah, it comes from Charlotte and passes through Shelburne, and I don't know, I mean, the cow, I don't see cows so much in the brook, like I think they've done a good job of fencing them out and whatnot now, but some of it may just be that old, you know, that legacy phosphorus, that those soils are laden with phosphorus already and they're clay, and so we get a storm again and they wash right downstream.
that was kind of in there.
Are there? Yeah. Okay. Yeah, and agriculture is not something that we've done much with, and at least in my time at LCI.
To talk about,
It is, yeah,
you
yeah,
wanna be respectful, you wanna support your local farmers, but in some sense.
and with it being a totally different agency as well, it's like a little bit of a challenge. So you have the agency of ag and they have their own rules, and like I'm not as up to speed on what those are, or, you know, how to address it, so. But we do hope to do some landowner outreach there in the caves. There's some areas where it's like, you know, it seems like it would be pretty straightforward to do a floodplain reconnection project or a tree planting, you know, buffer planting along the stream that just looks like it could use some trees probably. So we're working on some of those things, and we'll hopefully get a little more of that done when I have a new staff person, getting her up to speed, so gonna have a little more capacity coming up soon.
During the federal level, it seems like the environmental protection may not be really thought really good. So if they,
Yeah,
let everything go, funding doesn't pass the states, Vermont doesn't feel the pressure from the feds to make improvements, so they start to get rid of people.
yeah.
Like how bad is the situation and what they're doing?
Yeah, it's a good question. I mean, we have not had any funding directly pulled or stopped, so that's good.
You say we.
LCA
Yeah.
grants and whatnot. We do have several, I mean, I have like 3, maybe 4 federally funded grants right now.
I don't think the Lake Champlain project has lost any money yet.
Right, yeah, the basin
Last I
program. Yeah.
checked, they still had their funding, it's the additional. The grants that haven't been passed yet are the ones that are in crisis,
That
that
are
they potentially get grant for the wildlife crossing and things like that.
Right,
So
right.
anything that's not in the works yet.
Yeah.
Is really in jeopardy.
Yeah,
They could have called back. Going back.
yeah. Yeah, unfortunately. And I don't know, I mean, your question about if Vermont would pull back if they didn't have pressure from EPA to clean up the lake. I hope that wouldn't happen. I mean, we do have,
Budgetary pressures in all other areas. Look how Medicaid funding.
yeah,
A lot of what people think is Vermont funding is really federal funding and state administered too, so even if Vermont was interested,
Yeah.
you know, if that funding disappears,
yeah,
they have a tough time.
yeah.
Do you know how New York's doing with all of their efforts? Similar to Lewis Creek?
I think they're not in as good a shape. Like, I think there's just not the watershed groups as much that are, you know, kind of taking the lead on some of these things. I know the basin program, Lake Champlain Basin program, has been trying to like encourage New York groups to step up and do, you know, grow native plants and whatnot. But I know of like a few watershed organizations over there, but it's not like here. It's not like we have like a
It's a
whole.
lot stricter in New York, actually, with a lot of some of their regulations.
State is.
Mm,
Yeah, we've had a lot of struggles trying to do some things over there where they're very. Get a lot of permits and, they're very protective. And a lot of
Interesting.
I mean, Vermont, in my opinion, does a great job, and we have a lot of organizations that really do a lot into protecting our watersheds. We're very lucky.
Yeah.
In my opinion.
Yeah, compared to-
We have some flaws, but, but
Yeah.
there's a lot of grassroots work. I mean, Vermont Land Trust is one of them, you guys. I mean, it's a struggle with the state sometimes, but I think the grassroots organizations do a really good job.
Mhm.
I think it's
All right, well, let y'all go home. Thank you. Thanks for coming on tonight.